So here, the first we have EF. So there's 6 ways we could have chosen the first one. We happen to choose E here. 5 ways to choose the second. By the fundamental principle of counting, if there are 6 ways to do one thing and 5 ways to do another thing, there are 6 multiplied by 5 ways to do both things. That is to select 2 letters. However, we need to divide this by the number of ways of arranging 2 letters. That's just 1 by 2. So if we have EF, for example, we can't have FE. So for every combination EF, we can just turn it around. So EF becomes FE, or DF can be turned around to give FD. So if we just multiply 6 by 5, we will have 30 permutations. So this thing here is 6P2. 30 permutations of 2 letters from 6 letters. But that's too many. We have to divide out by the number of ways that can happen, which is 2 ways. 2 factorial is just 2. So it's pretty clear here when we're selecting 2 letters how this formula works. You see, we have twice as many as we need. We want all our 30 permutations to be distinct. To make them distinct, we divide by 2. So then we have 15 combinations. So we get our answer of 15. This is written 6C2. So you can see that 6C2 and 6C4 are the same. I'll just write it over here, 6C4. I'll just write this down again. And that's equal to 6C2. Well, you can see that. We can cancel the 4 and the 3. 6 by 5 over 1 by 2, that's 6C2. So 6C4 is the same as 6C6 minus 4. This 2 here is just 6 minus 4. So in general, NCR is NCN minus R. We just take this N and subtract R. And that makes sense because once we have selected 4 objects from 6, there are 2 left over. So when we have all the selections of 4 objects from 6 objects, then what's left must be all the selections of 2 objects from 6 objects. So that's why 6C4 equals 6C2. So you see that we have to sum all of these probabilities. So we have to sum all of these. And all these combinations will be the same. We'll have 4.75s and 2.25s. So we'll have 0.75 to the 4 by 0.25 squared. And we'll have 6C4 of them, or 6C2 if you prefer. I'm just going to use 6C4 for now because I just want to show the standard form. Okay, so we can have this combination or this combination or, so we have an OR situation, so we sum the probabilities. That makes sense, because summing them will give us a greater probability. If we were to multiply all these probabilities, we get something even smaller than each particular probability. That wouldn't make any sense. So we have many different ways that this can happen. Many different ways that x can equal 4. We've 6C4, 15 different ways in total. So to 4 decimal places we get 0.2966. Now I want to explain a little bit more about the binomial distribution, so I'm going to go further than just answering this particular question. So here's the answer to question 1. I want to discuss the general form of this probability here. Suppose we wanted the probability that x equals 3. In other words, 3 employees have hourly earnings greater than 12.8. Well, we'd replace this here with 3. And the probability that an employee has hourly earnings greater than 12.8 is P. P is 0.75. This is our P. And we'd be putting P to the power of 3 because 3 employees have earnings greater than 12.8. And if 3 employees have earnings greater than 12.8, then the remaining 3 must have earnings less. So this number here has to be 3. So you can see that this number here is equal to this number here if you write it in this form, and these two numbers sum up to 6. 3 plus 3 must, these two powers must sum to 6. So in general, if x follows a binomial distribution, this squiggle here means that the random variable x follows a binomial distribution with parameters n and p, where n is the size of the sample and p is the probability that an element in the sample has a particular quality. In this case, p is the probability that an employee has earnings greater than 12.8, which we saw was 0.75. 0.75 is p in our example. Then the probability that x equals r, where r is some number running from 0 up to n. N in our example was 6, and we calculated the probability that x equals 4, so r was 4 for our particular example, is given by ncr p to the r times 1 minus p to the power of n minus r. So you can see that this value appears here, and this power here, well, the sum of these powers, r plus n minus r, gives us n. So P is the probability of our desired outcome, that is that an employee has hourly earnings greater than 12.8, and this was 0.75, and 1 minus P is the opposite case. Sometimes 1 minus P is called Q. So in our example, P was 0.75, Q was 0.25. Let's suppose we want to calculate the probability that x equals 2. Well, n is 6. So to be 6c2, p is 0.75 for our example, and r is 2. 1 minus p is 0.25, and n minus r, 6 minus 2 is 4. You can see that these two powers add up to 6. So we just work out 6c2 on the calculator, which we saw already actually is 15. So we did 15 by 0.75 squared by 0.25 to the power 4. So this is the probability that exactly 2 employees have earnings greater than 12.8. Suppose we want to calculate the probability that x equals 0. That means that no employees have hourly earnings greater than 12.8. So we have 6c0, because r is 0, p to the power of r, p is 0.75, r is 0, and 1 minus p is 0.25 to the power of n minus r. That's 6 minus 0, which is 6. So this is the so 0.75 is the probability that any employee, that's P, that's the probability that any employee has hourly earnings greater than 12.8. This thing is really just 0.25 to the power of 6, because 6c0 is defined to be equal to 1. Anything c0 is defined to be 1. Doesn't matter whether it's 7c0 or 8c0, whatever it is. Of course, any number to the power of 0 is 1 as well. So we just get this number here, and that makes sense, because if 0 employees have hourly earnings greater than 12.8, that means that all 6 have earnings less than 12.8. So that's 0.25 for the first employee, another 0.25 for the second. So all 6 have earnings less than 12.8. So each of these probabilities is 1 minus 0.75 or 0.25. So we just have 0.25 times 0.25. We just have 6 independent events. So we're multiplying all these out, 6 of them, and we get 0.25 to the power of 6. So that makes sense. At the other extreme, let's look at the probability that x equals 6. Well, n is 6, so r is going to be 6, so we 6c6. P to the power of r, p is 0.75, 0.75 to the power of 6. 1 minus p is 0.25 to the power of n minus r is going to be 6 minus 6 now. Now 6c6 is just 1. That's the number of ways of selecting 6 objects from 6 objects. NCN is 1, of course. The number of ways of selecting n objects from n is 1. There's only one way you can do it. There's only one combination that involves all the objects. So this is 1. 0.25 to the power of 6 minus 6, that's 0.25 to the power of 0, so that's going to be 1. So we're left with 0.75 to the power of 6, and again that makes sense. We want all employees in the sample to have earnings greater than 12.8, so the probability of that happening for each employee in the sample is 0.75. They're independent events, so we just multiply them all together. So we're sampling 6 employees from a population, and each of these probabilities is the same. Now you might say that should change, because if we sample something from a population, person or whatever, if the probability is 0.75 for the first selection, well, it's going to be a bit different for the second selection. It's like if we're selecting, say, spades from a pack of cards. If we remove one of the spades, then we have one less spade in the cards, in the deck of cards. So this probability should be different. Well, it doesn't really matter here because we're dealing with a huge population of 100,000 people, say. So these probabilities are essentially the same. So if we sample without replacing, they won't really change because the population is so big. It's going to be 0.75 for the second employee and the third and the fourth and the fifth and the sixth, because we're only taking a sample of size 6 from a gigantic population. But if we sample with replacement, of course, these won't change. So the first employee is selected, then put back into the population, if you like. So the second employee is selected. Now there's a chance that this second employee is the same as the first one. But anyway, of course, it won't change in that situation if we sample with replacement. But usually we're talking about sampling without replacement here. So all 6 employees are different. But the probabilities are so close that we can say they're all 0.75. Suppose we were given this question. Find the probability that at least 2 employees have earnings greater than 12.8. So X is the number of employees out of 6 that have earnings greater than 12.8. So this is probability X equals 2 plus probability X equals 3 plus probability X equals 4 plus probability X equals 5 plus the probability that X equals 6. This is what we have to calculate, where X is the number of employees in our sample of size 6 that have earnings greater than 12.8. So that's what at least 2 employees means. So X could equal 2, because it says at least 2, or 3, or 4, or 5, or 6. Now we could calculate each of these, and I've explained how to calculate them. You know, probability X equals 2 was 6C2, the number of ways of selecting 2 from 6, by 0.75 to the power of 2, because we want 2 of the employees to have earnings greater than 12.8, so that's probability 0.75, times the remaining employees to have earnings less than 12.8, because we want probability that X is exactly 2. So this will be 4. So we have 2 plus 4 is 6. 6 employees altogether in our sample. And then we go and calculate this thing, and so on. Calculate all of these 5 probabilities, as I've explained how to do. However, there's a slightly quicker way we could do this, and that is by recognizing that if we add on to these 5 probabilities the following: probability X equals 1 plus probability X equals 0. So we've covered all the outcomes, all the values that X can take on, from 0, 1, 2, 3, 4, 5 up to 6. That must equal 1. So if we want to calculate this thing here, all of this line here, we can just shift these 2 probabilities over. So we can just get rid of this and write our problem as 1 minus the probability of X equals 0 minus the probability of X equals 1. So we have slightly less work to do here. So that's 1 minus, I calculated this thing earlier. Well, I wrote down how to do it. The probability that X equals 0, that means none of the employees out of the 6 have earnings greater than 12.8. That means they all have earnings less than 12.8. That's 0.25 to the power of 6. The probability that exactly one of them has earnings greater than 12.8 is 6C1 times P to the power of 1 times 0.25 must be put to the power of 5, so the remaining 5 must have earnings less than 12.8. It's 5 and 1 is 6. So this is quicker than the more direct approach. Use the fact that all the probabilities sum to 1.